Oh, I didn't bring water. I can use this?
Yes, that one. Thank you.
Just when, do you want to tell me when I start, or? Yeah, okay.
Yeah. Yeah.
Okay, good morning, everyone. I am Craig Williams. I'm a principal solutions architect with Amazon Web Services and our IoT team. I work with lots of our IoT partners globally, helping them with integrations, lots of architecture, hands-on kind of work. Today, we're going to look at AWS's integrated industrial IoT suite. And out of our IoT solutions and services, which ones do we have that can help you at the edge, right? So we have a lot of cloud services. We have over 140 different services, but we want to focus in on the ones at the edge. And to do that today, I will start by looking at AWS IoT Greengrass. All right, so we built Greengrass for a couple of reasons. It's a software package that runs on your hardware. And we built it because when you operate at the edge, you need deterministic latency. So we want low latency, and we want some tools and services that can operate disconnected from the cloud, right? We want to be able to process our data locally with that low latency. And then if needed, we'll send it up to the cloud. We also want to be cost efficient, right? We don't want to send all of our data up to the cloud. It can be expensive. And we also know from experience that a lot of data can be processed before you actually send it up to the cloud. And then lastly is the law of the land, right? We don't want necessarily for data to leave an environment. We want to be able to process some types of industrial data before we ever send it to the cloud, or just kind of keep everything locally. So to do that, we have, again, IoT Greengrass. These are the various components. We bring some of the cloud functionality down to your edge device. And so we have the ability to compute. We have broker environments. We have the ability to track the status of the actual devices in your environments. We have access to local hardware. And then, of course, we can reach out to, various components inside your industrial setting. We can talk to OPC UA servers, and then we can process our data. We can do machine learning, and then we can send that back up to AWS. So here are some of the components. I'm going to kind of deep dive on a few of these. We have a local message broker. This means that we can speak MQTT, and so devices that can already talk MQTT can connect to our broker. It's a publish-subscribe broker. It follows the same model that we have with AWS IoT Core on the cloud. So devices can connect. They can communicate with each other. If you want, they can send messages back up to AWS so they can be stored in the cloud. Along with that, the messages can wake up Lambda functions. All right. So for those who haven't heard of Lambda, it is our event-driven compute service. Instead of building sort of large monolithic applications, we rather focus on small functional blocks, right? So you can write 5-line, 10-line applications in a variety of languages. And so it's ideal for IoT, right? Every single incoming message can hit one of these Lambda functions. And so through the MQTT broker, we can wake up those Lambda functions. We can do some kind of compute. We can send a response message back to devices connected at the edge, or we can send that data up to the cloud. Next up, we have what we call local actions, right? Again, these are the Lambda functions. So I can write in a variety of languages. I've got Python, I've got Node, I've got Java, C, C++. I can really do anything I want with these Lambda functions, right? This is where I can run my machine learning frameworks. I can do predictions. This is where I can filter data, pre-process it. I can, again, send it back up to the cloud. And the Lambda functions as well can access anything on the host, right? So again, Greengrass is a software package running on your hardware. It can run on really small commodity hardware, it can run on server-grade hardware. And it can access, like GPIO, it can access accelerators. All of that is available to the Lambda function. So it brings like the ease of cloud development to my edge environments. On the cloud, it's really easy. I can write code in a browser. I can click a deploy button. Now I can do the same thing. I can have this piece of hardware anywhere in the world. I can remotely update this code. I can debug it, right? So as these Lambda functions execute, and if it's Node.js and I have like a console log, I can take that data. It's routed within seconds back up to AWS, and I can see it, right? So I don't have to have the more traditional way of figuring out how to run a Python script. I can also have these Lambda functions. They're designed to be event-driven, but I can also have them long-running. So if I want to connect to like a serial port, or if I want to connect to an OPC server and pull tag information, then that's something I can actually do inside of these functions. We support state information and data synchronization back to the cloud, right? So for command and control, I never want to send control messages to devices without first understanding the state of those devices. And so we have shadow concepts that we have in the cloud that we also replicate within Greengrass itself, which means that I can first look at the state of a device. I can inspect that shadow. It's maintained by Greengrass itself. Then I can send a control message to the device. Once it receives it and processes that message, I can see the state change. And then I can also replicate any of that shadow information back up to the cloud. So in cases where I have a control environment and my operators are outside of that environment, I can synchronize my shadow up to AWS, and then those operators can make changes and will automatically synchronize that back down to Greengrass. So for security, we have a really high security bar. When you connect to AWS IoT in the cloud, we require TLS 1.2, we require mutual certificate authentication. There is no option to actually downgrade the security model. We support exactly the same thing for Greengrass. So for every connected device, we require to support TLS 1.2. So make it easy, right? We want to make sure that every single device connects using that model and that your data is always encrypted, right? It's encrypted going to Greengrass. Anything from Greengrass going back up to AWS is also encrypted. Local resource access is just a little more on actually being able to reach out to local hardware. So when the Lambda functions within Greengrass run, they have a high degree of isolation. But I can open that up, right? So I can say, okay, a particular Lambda function can actually talk to GPI opens or reach out to the file system, right? Or actually get access to a GPU on the actual physical hardware. We also support machine learning. So the way we do this with Greengrass is up in the cloud with AWS, we have a service called SageMaker. SageMaker is where we will train the models, right? And we also support our deep learning compiler, so we can optimize machine learning models. Once SageMaker has compiled your model, it gets synchronized down to Greengrass, and then within the Lambda functions, we can actually run things like MXNet or TensorFlow, or you can run our new optimized Neo machine learning runtime environments to actually process those models, make predictions. And then the Lambdas themselves can get access to the physical hardware again. So I can get access to like a video stream. I can grab every frame. I can send it to my MXNet environments or OpenCV, things like that. So that was Greengrass. Now, when we look at how we operate at the edge, what about smaller devices, right? So Greengrass was designed or is designed to run on Linux environments, right? We expect it to do a lot, so it's not something that can run on microcontrollers. But we do have a solution for microcontrollers, and that is Amazon FreeRTOS. Right, so Amazon FreeRTOS is our additional SDKs and libraries built on top of the very popular FreeRTOS operating system. We bring local connectivity libraries, we bring our cloud connectivity libraries, our security, and we also support OTA through our device management platform. So Amazon FreeRTOS extends the #1 real-time operating system. It's been around for over 15 years, 40 plus supported different architectures for it, completely free and open source, and we completely maintain that project now. With the local connectivity libraries, we give you the tools to be able to manage your Wi-Fi connections, to be able to manage Bluetooth connectivity, and we also developed the iOS and Android SDKs to make it really easy for mobile phones to then actually communicate with the Amazon FreeRTOS or the microcontroller that it's actually running on. So this is useful for, especially for provisioning. So when I'm provisioning new hardware, if I have a piece of equipment to take a dumb water pump and make it smart, I need a way to get my certificates onto that initially. And so we'll use something like a Bluetooth connection from a mobile phone to talk to a microcontroller running on that, hand my certificates off, and then that pump can connect directly to something like Greengrass. We have our security libraries as well. So we want to make sure that when you connect from the very edge of the edge, from your microcontroller all the way to Greengrass and then up to the cloud, that your connections are absolutely secure. So we have support then for TLS, our certificates. It's secure by default, and we don't allow any open ports to be running on that microcontroller. And then we support OTA. So we have two different components for OTA. For some of our partners, they've got microcontrollers where Amazon FreeRTOS has already been certified. The OTA component and implementation has been handled for you, which means that once you buy that, you can issue an OTA job, which sends a JSON payload to the device. The device can then receive a signed firmware image, and it can do its updates. If your microcontroller doesn't support that, you can still do the implementation, right? So you can receive that JSON payload from the job service and then actually do the upgrade. And then we include the device defender libraries. So that's actually next on my slide, which is how do we make sure that your devices are secure? And that's not just for compromises, but what happens if you had a bad firmware update? How do you detect that something's actually wrong with this device now? And we do that with Device Defender. So the Device Defender libraries are included with Amazon FreeRTOS. So Device Defender has two components, right? We have a cloud component to it, which allows us to look for anomalies in the incoming data. So we can actually look at how much data does the device send, what happens if my device was sending 5 megs an hour and it's suddenly 50, or so I can trigger workflows. If there's a change in how much data a device sends, I can look for certificate reuse. So maybe I have a compromised certificate, or maybe I have developers that are sharing device certificates. And I can also look for things like expiring certificates, right? Any of these anomalies or compliance issues, we can then kick off a workflow to mitigate that, right? So it could be that you kick off something to do a certificate rotation and generate a new certificate, push it down to your device to use, and then revoke the old one. So we do audits as well. Along with when our certificates expire, we can look at the security policies attached to every single certificate and make sure that developers haven't created an environment where you have an open policy or a device is able to subscribe to any number of topics. Any of those sort of compliance issues we can detect and then audit them. Along with that, when we look at compliance, the agent running on the actual device itself can report a certain amount of data from the device. So it can look for things like open ports. And if you have compliance around that, right, if it's it doesn't have to be a microcontroller. It can just be a Greengrass environment or some kind of Linux environment. Then we can look to see, is port 22 open? And we can flag it, and somebody can go and deal with that device. We provide a dashboard and just a mechanism for you to kind of visualize what's happening with all your different devices. Again, for anomaly detection, we have models to kind of look for anomalies. And anomalies could be compromised devices, but they could also just be, that a device is malfunctioning or that I have bad code, right? And I can send an update to that. And then for the alert mechanism, you really have everything available to you within AWS. So you can kick off a job to our device management platform, which, like I said earlier, is a way for you to actually rotate certificates for that device. You can also downscope credentials for a device. You can revoke certificates. Any kind of action you want, send in SMS messages when something's out of compliance or there's some kind of risk with a particular device. Since we integrate directly with device management, really, we have a few things there, like revoking permissions, rebooting devices, but you can really kind of send any payload to a device that becomes out of compliance with Device Defender. Okay, so if I'm collecting all this data, I might be processing a lot of it within Greengrass, but how do I actually get value from my data? What can I do now to actually analyze that data? And a lot of this we can send up to the AWS IoT Analytics service. The service I like to think of as it's ETL for IoT data. All right, so I can collect my data, I can send it through a pipeline to transform it, to enrich it. I can then store it. So I'll talk about the storage engine underneath that. I can then analyze that data, and then I can send it to any sort of downstream service after that. So getting data into IoT Analytics is done through something called a channel. And we allow you to ingest data from IoT Core itself, which means you just publish to certain topics, and we can route that data into IoT Analytics. You can publish directly to IoT Analytics, which is what Sitewise does, which I'll talk about next, which is our industrial solution. We also allow you to detect events when data is stored on our simple storage service, which is S3. And so once data arrives in a channel, we send the data through a pipeline, and this is where we do our ETL, right? Our pipelines allow you to enrich your data, connect to local data, databases in the cloud, add any additional components to your messages or potentially filter them. And then when we store them, we have a time series database within IoT Analytics. And you really have an unlimited amount of data that you can store inside of the time series databases. You can have as many of these as you want. We allow you to set data retention policies on them. But yeah, you can have terabytes, you can have petabytes of data available in the time series database. And when we store it, we partition everything by time keys. Once you have the data inside the time series database, we use data sets to pull it out, and then the data sets are what you hand off to things like SageMaker, right? So SageMaker is our machine learning service. You can send your data to that. You can make data sets available to third parties. You can just simply extract the data, and the data sets run on a cron job system. So every 10, 15 minutes, you can update your data sets with whatever streaming data is coming into the service. All right, so next up, we want to look at some of these services we spoke about, IoT Analytics in Greengrass, and a solution we built that starts to combine these services and actually focus them in on a particular vertical. So we know that for manufacturing, mining, oil and gas, and agriculture, that a lot of the data is never analyzed, right? It's sitting on premises, or it's just simply thrown away. So we have a service to be able to try and ingest as much of that data as possible and make it really easy for you to get access to it, to learn from it, and then to also work with real industrial data as it's streaming in on top of the existing data that you already have. So that service is Sitewise. It consists of a remotely manageable device gateway that actually is on site. It allows you to build customizable views and then build models and actually manage your data. So again, this is a physical device that we currently have this service in preview. But the way this will work is you'll work with one of our AWS partners. You'll have a physical device that you can set up on site. It's really easy to get up and running without having to write any code. That product can then connect to your industrial system. So it can connect to OPC UA servers, or it can ingest Modbus data, or it can connect to historians to ingest existing data that you have. And then it funnels all that data up to IoT Analytics, where you can then do further processing on it, right? So it's a really easy way for you to just ingest that data in mass, and then also to be able to pick up your streaming data and get that up into AWS. So once we have the data, you can then build customizable views. So this is actually a dashboarding system that we have. You don't have to rely on any third-party services, and you can go in and you can actually you can build dashboards to look at not just the data coming off one device, but the idea is that if you have multiple lines, you can then get a holistic view across all the lines for your entire operation as the data streams in, right? And I mean, each line might have different configurations at the edge, and the idea with SiteWise is that you can connect to the disparate systems, pull all that data in, and then get a centralized view for everything going on. And then we give you the tools to actually build models to map everything that's actually happening in your environment. So one of the last services I wanted to touch on was IoT Events. And so we have all this data coming in. We have it coming in through lots of different systems. You know, how do I actually act and respond to, you know, the state of these various devices? And, you know, typically I might have written business logic that existed in, you know, large applications or large Java applications. And that's something that's actually hard to scale. And it's hard to visually just be able to look at your data and understand what's happening, right? And so we wanted a way for customers to not just look at the state of devices, but to be able to actually build complex events, systems around the data as it streams off of devices. And so with IoT Events, I can build models for the devices themselves, and then I can configure what the state, you know, the state for these, and then as the telemetry streams in, the state and the model get, you know, the state itself gets updated, and I can combine the state across multiple different types of devices. And then we can do it at scale. So I don't have to think about the fact that I may have, you know, hundreds of thousands of devices streaming telemetry. I can, you know, it's going to scale to deal with that for me. And then I can also connect it to things like SiteWise. So we just said SiteWise can ingest all this existing data and then make it really easy to stream in data from my industrial systems. I can then now funnel that through IoT Events. I can make complex decisions. I can actually build, I can orchestrate a workflow of what, you know, of the events and what I want to take place. So if I detect a device in a certain state, I can then issue messages across our broker, so I can send messages back to something like Greengrass, where we can actually send control data back down to the edge. And then I can also integrate with SageMaker so that I can do predictions. And so we can actually detect and predict that a device is going to reach a certain type of state. So here for the event detector models, this is what I'm defining for each of the different types of devices, and I can evaluate multiple inputs to derive the state of the bits of equipment that I'm trying to track. Like I said, you can integrate with other AWS services, and so I think SageMaker is one of the most powerful ones that we can, because we can make predictions, right, on the state of our devices, get that into our event system, and then be able to predict state changes on various telemetry as it comes in. And then it scales for us, right? It's hard if you have lots of devices, right, to scale your own kind of event system. And so we give you the ability to do that. And then my last slide, hopefully you can kind of see it. This, I just wanted to put up, this is kind of our everything slide. So we have this at our booth as well. We have a lot of services that go all the way from the left of this diagram over to the right-hand side, which allows you to connect your devices really securely, make it easy to do that as well. Everything on the left-hand side is like from the microcontroller level all the way to edge gateways and devices where we can, you know, this is where we can process. We have, let's see if this works. There we go. So we have Greengrass and we have SiteWise operating either on your hardware or on a SiteWise device to be able to ingest and process my data, run my machine learning models, and then once we get up into AWS, these are are different cloud services. So IoT Core, device management, we spoke about Device Defender, Iot Analytics. We have a lot of these services that you can use in various configurations to then be able to process your data. And then up here we have our enterprise applications. So SageMaker is, again, where we do our machine learning, and we can synchronize the models and things that we train there right back down to the edge side. And then lastly, we have a lot of different partners, so you can come and see some of the hardware that we qualify at our booth. So we work with a lot of hardware partners to make sure that things like Greengrass and our IoT SDK and Amazon FreeRTOS are qualified right on that hardware so that you know when you're working with it that it can work with all our various different services. Okay. And then lastly, I do have some AWS IoT Socks here. I have a whole bunch of them. So I'm going to take the mic off, but for those who want to come up and find us at the back, we'll be giving these out to those who ask questions. All right. Thank you.